My name is Tomáš Kukrál. I work here at the Faculty of Information Technology as a system administrator, and I'm responsible for a Ceph cluster. And I would like to tell you something about monitoring Ceph with Prometheus. And this talk is in English, but if you have any problems with understanding my English, because I'm not a native speaker, please don't hesitate to interrupt me and ask me anything. So first, Joe has already given you some introduction to Ceph. I will make a small review for newcomers, and then I will focus on Prometheus, and the last part will be about combining Ceph and monitoring it with Prometheus. So Ceph is a distributed object storage. It tries to be self-healing, scalable, and fault-tolerant, and it basically gives you one extra worker in your company. It means that if one of your drives failed, Ceph will wait some time, give you the chance to fix it, and if you will not be able to fix it, it will try to fix it for you to get back into the health state. But there are some consequences, as usual. There is a basic architecture of Ceph. I think it's the simplest one. And there is an OSD. I will use it for object storage daemon. And as Dominic already mentioned, it can mean also the disk on your storage. The OSD is a main component. And the second very important component is monitor. It's here on the black box. The blue box. And this monitor is responsible for monitoring the whole cluster, monitoring that the OSDs are up. It also knows the maps of your cluster, so it knows where your data are actually stored. Next important part is a switch, which is connecting the OSDs, monitors, and your clients. I'm not going to talk about the architecture and reference architecture, but you definitely want to have more than this one small switch. And as you can see here, the clients are connecting to Ceph via the network. And the important thing about Ceph is that when the clients want to read some data, it first downloads the cluster map from monitor and then connect OSDs directly. And there are three areas which should be monitored by your monitoring solution. It doesn't depend whether it's Prometheus, Singar, Nagios, or something else. First, you want to know that your cluster is in a good, healthy state. Second one is monitoring of cluster components, because your cluster can be in a healthy state and totally fine, even if some of your components are failed. For example, if one of your drives is failed and you have enough of drives, so one failed drive is not a significant part of your cluster, sorry. So cluster will rebalance and will be back in a healthy state. And the last important thing is the hardware. Ceph is sometimes called like a software storage, but this software storage is backed by the hardware, and hardware is necessary for Ceph. So first area was the cluster state. There are different metrics which can be used to monitor your cluster state. As I already mentioned, there is a cluster health. It can be obtained by the Ceph health detail command, and it will give you just the decision whether the cluster is failed, whether the cluster is healthy in a warning state. It means that something is wrong, but it's working. And the last state is critical, and if your cluster is critical, then you have a really bad problem. Next thing is a placement group, is an abbreviation of the PG. And the placement group is something like an inode for a file system. It's used to connect your data with a place where it's stored. And you would like to ensure that there is a right number of placement groups. It shouldn't change on its own. And you want to know that the placement groups are in active and running state, active and clean state, sorry. You will see it on later slides. And also it's good to monitor the performance, because if you just deploy your Ceph cluster, it will be working just fine. And after some time, you can get more clients, and your performance degrades. So it's wise to run some performance tests and monitor the results over the time. And maybe the most important command of monitoring Ceph cluster is Ceph/w. And it will open standard output and print you the information about your cluster. And I will be using this for monitoring with Prometheus on the next slide. So second part are the components of the Ceph. The most important one for a basic setup are OSDs and the monitors. And you want to ensure that you have the right number of OSDs. I think that you will never come to a situation that somebody will add more OSDs in your cluster and somebody will give you more disks. But you can see that some of your disks failed, and there will be not enough of OSDs. And you want to also ensure that OSDs are in good state. There are 4 states: in, out, up, and down. And you want to have all your OSDs in state in. It means that they are in a cluster, and you want to have it up. You want also ensure that there is enough of file system space on your OSD drives. And actually, there is one metric. It's the last 2 lines, and it can be configured in SafeConfig. And I would like to suggest to you to lower these values. I think that the default value for full ratio is 95%, and the near full is 80%. But it will not give you any space to fix the problems. For example, if one of my OSD will hit full ratio, I will not suggest you to do it. It's really bad practice to do it. And I think that you really don't want to experience it. And if you will have this full ratio set to 85%, and you will hit this ratio, that all the writes and reads will stop, and Ceph will not allow you to make any operations. But you can change your config to make it 90%, and you have 5% to fix your cluster or add more OSDs. Next thing you want to monitor is that you have a right count of monitor daemons, and the monitor daemons are in good state, and they are able to form quorum. Here at the right side are commands which can be used to monitor the components, but there is one problem. There is not any command which can print you all information. And usually some of the commands, for example, Ceph mon status will return JSON, but the rest of the commands will return just plain text, and you will have to parse it on your own. Can you see it? Can anybody see it? I will try to explain it. There is the output of SelfCommand. This command I have written here. And there are information, basically every information about the cluster is here. The long number at the second line is a file system ID. You can see that there is a health OK, that my cluster is fine. There are written number of monitors. They can form a quorum, and quorum is on the last, I think, 5th or 6th line. And you can see here that there is a OSD map, and there is 15 OSDs, but only 14 of them is up, and 14 of them is in. It probably means that one of the OSDs failed, but still Ceph health is OK, and cluster is running. And the last 4 lines, it should be one-liner, but I wrap it to fit on the screen. The last 4 lines prints all the information you need about your capacity, almost all information you need. There is a PG map. It's a number, something like a timestamp, but it increases over the time. And Then there are the PGs, placement groups. You can see that I have 320 placement groups, and all of them are active and clean. And there is also some data about the cluster that this is only the testing cluster, and we are using about 150 gigs of data, and about 500 gigabits is used. And the last area which we want to monitor is the health of your hardware. I think there is nothing special. Maybe processes with blocks I/O or network utilization can be a little bit special for Ceph. And we are also monitoring uptime. I will describe the reasons later on the end of the presentation. So, as I mentioned, I'm working here at the faculty, and this is our new cluster. We have 7 servers, and since this cluster is very small, that we are running monitors on same hardware as the OSDs, and there is 56 OSDs and about 200 terabytes of capacity, and we use it mostly for disks in OpenNebula. So it's basically backup for our instances, and we also have few running containers using Ceph as a persistent storage. So, the Prometheus. How many of you know Nagios or Itzinga? Okay, everybody know it. So please forget everything what you know about it. At least when we are talking about Prometheus. There is nothing like a check. Forget about checks, you have never seen it. Because Prometheus brings a totally different approach. It doesn't run any checks or this kind of stuff. It just works with the metrics. And Prometheus is time series database. It just downloads the metrics and save it into the database. So you have something like a timeline of outputs of your metrics, not the checks. And also you are able to make any queries. You can ask Prometheus, how many of free space I have now, or how many of free space on disks I will have in 2 hours, or how many services named something are running in my cluster. And the last thing, which can do Prometheus itself, is alerting. It can make any query and decide whether it's necessary to fire an alert. But it's not sending any notifications. Notifications are delegated into other service. Prometheus is quite efficient, and it's not using too much space to save the data. And also it's efficient in a configuration way, because you will install it very quickly, and it's very easy to configure it. Actually, it's not as easy, but you will add not much lines in the configuration file. Compared with Nagios, it's really easy. And the elementary part of Prometheus are endpoints. Endpoint is something, basically it's URL. Sorry, I'm not able to say it. URL. And Prometheus periodically downloads files from there and gets metrics, parse it, and save it. So only thing you will be changing over time in your Prometheus is adding more hosts. But if you are lazy as me, you can use any discovery system. So you can get the endpoints from any other system. There is a support for DNS files. There is a support for getting hosts from Zookeeper, Consul, and I think even Kubernetes. And you can also get metrics from cAdvisor directly. You don't have to run any other service. So in this picture, you can see a simple architecture of the Prometheus. It's a blue. What is the color of the Prometheus box? Who thinks that is blue? I think the Prometheus is in a box, isn't it? It's a white box. I think it's white. I think it's blue or green. So it doesn't matter. There is a Prometheus in a box. And it's a Prometheus itself. And the Prometheus is periodically checking the exporters and downloading data from them. You can imagine it's something like vget or curl or something like it. It is doing much better way, but it just gets metrics from exporter. And the latest versions of Grafana is also support for getting metrics from Prometheus. So you can draw your time series from Prometheus directly with Grafana. And there is last component is the alert manager, and this service is used for sending the notification. It works the way that Prometheus creates an alert and send it to alert manager, and this alert manager can decide whether it's necessary to send a notification, throw it away, or it have many other functions. It can, for example, group your alerts. You can imagine that you have 50 nodes in our Kubernetes cluster, and you forget to silence your notification, and then you turn all of them down. So you have 50 machines down. And alert manager will not send 50 emails, or even worse, it will not send 50 short messages on your phone. It will just send one message, and there will be written, these alerts was fired 50 times. So it can do some basic grouping. And as I mentioned, that Prometheus is very efficient. There is configuration for Docker Compose to run Prometheus. And actually, we are running almost same config in production. Actually, there are two more containers for Grafana and the database for it. But you need just this to run Prometheus and start it using in a simpler way. You can see that it has some data and config and almost nothing more. So as I mentioned before, everything in Prometheus is a metric. But this metrics is not simple as something like a variable, but they call it multidimensional. It means that you have some metrics, and its name is LinuxDays registrace, for example. And the value is 1179. And you can add labels to this metrics. So this metric has label named group, and the value of the label is LinuxDays. And you can combine these metrics. You can see that on the first line, there is a second label called prat, and the value of this label is def. And you can make any filtering on queries according to these labels. Yeah, you can see some queries here. These metrics will give you information how much space is available at your file systems. Usually, bytes are used as a size unit, so you don't have to parse it, whether it's gigabytes or megabytes or anything. There is just in bytes, and you can do advanced queries with regular expressions. So you can see here that I'm asking only for metrics with label mount point, and I want this label mount point to start with this path. And this query can give me information how much space is on all of my OSD drives. And I will give it in one place for all hosts. Yeah, this is my favorite. You have more functions than just querying. There is an average or absolute value on these boring functions. But this one is much better. It can predict your future. So basically this one will give you metrics, LinuxDays registrace, give you samples only for last 10 days, and to predict how many people will be registered for LinuxDays in 1 year. Can you guess how many people would be registered in LinuxDays if the registration will take 1 year? Any number? I don't have any gift for you, sorry. 400,000? It's a fairly big number. This number? Isn't it such a big number? It's about 20,000. I will show later the graph of the registrations, but I'm afraid that it will not work this way because everybody wants to register in last day. Yeah, back to efficiency. There is Ansible task, which we use for installing monitoring system on physical nodes. And you can see here that there's a huge load of dependencies and many packages. And these dependencies has another dependencies. And the most funniest dependencies are, for example, postfix. Really, anybody wants to have a postfix on your virtual machines or instances? Or some of them, especially the monitoring one, have a dependency Samba. And some of them even start them. Yeah, I want to have a Samba running on my instances. Exactly. So Prometheus just required to have one single binary. You know, it's written in Go. Everybody writing Go this way. It has no other dependencies. It's really easy to configure it. And the last one, it's really great because you have told me that almost all of you, use Nagios. And do you use Nagios remote execution plugin? This is the system which runs your check on your remote machine and give you values back. And for example, if you want to check load, you will write something like, I don't know, check load. It's quite fine, but no, you have to print how much of load is fine and how much of load is critical, for example, 100. And you have to configure it in every machine, in every instance. And if you want to change this, for example, to 18, you have to change it on every machine. And I think it's really weird to configure it this way. So in Prometheus, actually it doesn't run any checks, but decision whether something should be an alert or not is on a Prometheus itself, and you configure it only on one place. So all the time I was talking about metrics and getting the metrics from an endpoint, but first of all you need to create some endpoint. But cool Prometheus guys prepare it for you, and you can just download this node exporter. It will open on port 9100, and it will export all of your metrics for the rest of. Basically, it will give you every information about your machine, what you need to have. I will try to show you some example of the endpoint. Yeah, there is just simple text file and Prometheus. No, I will have it on the next slide. And it will export all information to you. And the job for Prometheus is to download this metrics and save it into the database. Yeah, and now, if you have node exporter and the Prometheus, you can monitor your physical machines. But as I mentioned at the beginning, I would like to have more metrics, for example, about the Ceph, about the placement groups. And I would like to have them in my Prometheus system. So I was thinking about how to do it. I can write something or have some parser for configuration. But then I discovered that the node exporter I have mentioned on the previous slide is able to read text files. So I developed a daemon called SafeWatch. I think it's on the next slide. No. Called SafeWatch, and this daemon, this one with the octopus, is exporting files into the node exporter, and these files are read by the Prometheus. So I have two daemons running on my machine, but it's necessary to run only on one machine, on my monitor. And it exports all information about the Ceph cluster. But monitoring Ceph is fairly funny because, as I mentioned, there are some placement groups, and there are states and each placement group can be almost in any state of it, and the states can be combined together. For example, you usually want to have active and clean, but you can have active, degraded, backfill, paid backfill, or anything together almost. So it's not as easy that I want to say, oh, I want to graph this way and this state. So I wanted to make it more versatile. So I created SafeWatch. You can take a look at it, but I'm not Python programmer, so it's working, but I think that it don't have to be nice. You can check it and send me pull requests if you want. And it's exporting these metrics. I hope it's possible to see it, at least a little bit. It's exporting timestamp. It's used for watching for stale SafeWatcher, because if the daemon stops, the file with the metrics will stay here until it's deleted. So I need to check that this file is refreshed sometimes, and then it uses metrics for Prometheus as I described before. For example, metrics called Ceph PG state have a label, and the value of the label is state of the group of PG groups, PG map. So I would like to have active and clean 1032, but you can see more metrics, and it's possible to make a graph of it. I think it's obvious that I usually monitor just active and clean, and if it's anything else that I would like to save, make an alert and send a notification. And there are some more metrics. For example, Ceph capacity is just exporting the last line I have presented for you. I think this should be about 1080 terabytes. We'll see it on the next slide. So this daemon is constantly running on one machine in my cluster, and is exporting these metrics. And the role of Prometheus is to download it periodically. So I was afraid that you wouldn't trust me if there will be no demo, so I'll try. Any questions? Okay. I have prepared two containers here, as I mentioned as I showed you on previous slides. There is one container with Prometheus, nothing more. We will not be trying alert manager. So I will start it. There is almost nothing in the configuration, and it should start listening on my local host on port 9090. Oh. There is a web interface of the Prometheus. First time I saw this interface, I was looking for checks. Then I was looking for an alerts. So there is nothing in alerts by default. But the most important thing is here targets. Actually, there is nothing in targets because we are not monitoring anything. But I will open configuration. And you can see that in my configuration is nothing. I have defined that I want Prometheus to check it every 5 seconds. And I will add the configuration this way. And there is written that I have some script job called LinuxDays. It's getting this path. It's using HTTPS and this target and some labels. Usually it's much simpler because you shouldn't be using HTTPS and you are running on /metrics. So I will start it and restart Prometheus, or send the signal to reload the configuration. And now, after some time, in my target is the endpoint, the LinuxDays count. There is error in last version. There is missing slash. but you can click on it, and it exports that we have 1,187 people registered. So still nothing, yeah, it's showing up and down, so you can monitor whether your endpoints are up and down or anything. But there is a graph. Actually, there is no graph still, and don't expect to be any graph for like a persistent. Each time you will click on a graph, there will be nothing like that. But you can print some metric, and it will show you the value and the graph, but it will not be there because we started just now to scrape the configuration. But I have another Prometheus instance, which is running some time, and I will make a same query here. And you can see that the value is the same, and there is some graph. Yeah, there is some graph of the number of registrations. And I think it was fairly simple, and I just needed to export one endpoint. And this endpoint can be exported by the node exporter if you don't need any special like number of the registrations. Do you have any questions? Anybody? Or you are bored to death? So, okay. Next demo is much better. I will show you our testing Prometheus, and I will show you how we are using Prometheus and Grafana to monitor our system. I will connect on different machine. There is same Docker compose as I showed you before. Oh. There are 4 running containers, I think. Yeah, the Prometheus, Alert Manager, Grafana, and the database for Grafana. And it's running on this URL. It's Grafana. I really like the way how Grafana is connected to Prometheus. I will show it to you later. And there is more of targets. I don't know how much of them is here. And you can see here the LinuxDays target and there is some machine, I don't know what is it. Yeah, GitLab target. And there are all of the Ceph clusters and some other. But most interesting is Grafana. Yeah. We are showing there some basic metrics for Prometheus. We are showing how many OSDs are up and running, how many monitors, how many data. You can see that it's basically parsed from Ceph status, but this one is special. It predicts how many storage will be used in 1 year. And this one can also be used for alerting. So you can create an alert, and if the use storage will be more than your capacity, you can send, I don't know, email to your guys to bring more disk or something. We are drawing graph of PG states, but it's fairly boring because everything is active and clean, and sometimes some deep scrubbing or something. We can take a look in the past. Yeah, I think it was something was here, but our cluster is quite healthy, so nothing interesting is here. We are graphing the cluster capacity, some memory. You can see here that cluster is doing some scrubbing, usually at 10 o'clock, and after the scrubbing, memory there is more memory than before. Sorry, my computer is quite slow. This is a mistake of the Prometheus, but it's browser itself. I'll try to do it this way. Or maybe just somebody disconnected me from my draw. Never mind. Next demo. This is just monitoring with graphing, But one thing you will certainly need for your system is alerting. Oh, that's fine. And we have defined some alerts, and these alerts are defined in Prometheus exactly this way. I will define that I want to include some alert file, and in alert file are alert rules. These rules are evaluated each time when Prometheus downloads the metrics. Oh, no. I don't want anybody repeating my tweets. Yeah, exactly. These alerts are defined in this really simple way that if up equals 0 means that Grafana doesn't want me. Never mind. I can try to print it here. If up means 0, it means that the instance is down. If up is 1, so the instance is up. It's really simple, I think. And if this state, something is up or is equal 0, is for 10 minutes, then I want to fire some alert. You can see it here that in alert instance C2 service ICT fit CTU CZ is down, and the alert is firing. But actually, I didn't have any notification. I have many notifications from Twitter, but no notification from Prometheus. Because I'm firing an alert, but I'm not sending a notification since I muted this notification in Alert Manager. I will show it to you later. Next alert which we are using is this one. You can click on it, and Prometheus will show you the command, and you can see that nothing is here. And basically, it looks at all machines in group hypervisors and matches services called libvir service and libvir guests, and ensures that everything is up. So if I will stop something on some hypervisor, I can try it. I think that this one is not used. I hope so. So I will stop libvir daemon. Yeah, it stopped, and we will see after a while whether it will do something. It's not immediately because, as you can see here, we are scraping our hypervisors each, I think, 30 seconds, so it will take some time to make an alert. And I hope nobody have muted it. And the next alert, which we are using for like a generic one, are file system full. I think it's fairly simple and nothing special. But file system full in 30 days is not very special, I think. And I think that it will be really hard to do it with for example, Nagios or any other similar system. You can see that it takes some time because it needs to take all samples for last 5 days, and for every machine, make some prediction and compare it with the other metrics. So it sometimes takes a really long time. And you can see that nothing is here. So there will not be probably any problems with our systems in next month. We will not run out of the space. And last metrics are special for Ceph. And this one is funny. We are monitoring long uptime because we don't like bad servers or this kind of stuff. And we would like to ensure that all Ceph servers are able to reboot. They will start if we will have to shut down them. So we will try to reboot servers at least each 127 days. So if any machine have a longer uptime than this one, it will fire an alert and we will reboot it. You can see that nothing is here, but if I lower it, it will take some time, as previously, but there will be some machines. Oh. Yeah. There are machines which have longer uptime than 100 seconds. And next, yeah, I want to leave this many times. And next alert which we are using is we are counting that we have right daemon count, right number of PG placement groups. All the placement groups are in active and active and clean state, and we are watching that our SafeWatcher is stale. If it doesn't export new metrics in 10 minutes, that it will fire an alert. And as I was speaking about alerts, but the Grafana is back, I hope. Yeah, you can see here that the libvirt down is in state pending. It means that it was down, but it wasn't down for 10 minutes. And in about 7 minutes, it would send notification that libvirt on one of our instances is down. Last things I wanted to show you is how hard it is to add Prometheus to Grafana. We'll just this way. You will select the data sources. Yeah. Data sources. Yeah, this one. And there is basically everything you need to add to your Grafana to print data from Prometheus. If you are not using authentication and this boring stuff. But you just paste this URL into your Grafana and you are able to make these dashboards. Yeah, it started working. This one was interesting. That, as Dominic already mentioned, Ceph is trying to balance all the data and store it in a random way, but on your OSD should be same amount of data. I have just requested him the Grafana to print data for last month, so it will take some time, and on this network it will take even more time. It's usually working very fast, but it's a live demo. Can try to open it this way. Yeah, and redraw. It will take some time, so I will show you Prometheus alert manager. And you can see that there is one alert silenced, and this is a machine which was down in a list of the targets. And there are some alerts, and if we will hide silences, nothing will be there because the alerts. Oh yeah. Funny, very funny. Alerts are sent after the alert is not in pending state, but in firing state. So this is the demo I have just showed to you, and it's everything I prepared for you. If you have any questions, I'll be happy to answer them. And anybody have a question or some comment? If you don't have any questions, okay, I will try to. Is it working? 1, 2, check. No, it's not. 1, 2, 1, 2. Can I try? It's booting.
Yeah. Okay. So you mentioned you're running a daemon to actually get some data from the Ceph cluster on one node.
Yeah.
What if that node fails?
Sorry?
What if that node fails?
So I will get the notice from Prometheus that some node is down, and I will get the notice that my watcher is stale. So I will get the notice that there are no updates in my exporter.
So in the meantime, if anything else fails, you have no idea what's going on.
Yeah, I'm not getting my data.
So now my real question, is it possible, or is it, it is possible, but is it possible in some sensible and easy way to actually have multiple endpoints, multiple paths to virtually one endpoint? Because you can get the same data from all the monitor nodes.
Yeah, exactly. You can have as many data as you want, and you will need to update your queries. Because now I'm using query to get some data. And if you will have more exporters, you will have to say that you want to have one of the exporter or the first one. But you can have as many endpoints as you want, and you will need to select a right endpoint with your query.
So I can actually have multiple exporters on multiple nodes for the same data, and just use the one which is not stale for the...
Yeah, exactly.
Perfect, thanks.
And I have prepared this daemon for you. Yeah. There is, on the production servers, it's running in systemd unit file, but there is just one Python file, which is, I think, less than 100 files, 100 lines long. And it's just... And it's just reading Ceph, this command, and parsing it and exporting it. You can see the file is changing, at least pgmap is changing. And it's basically same, it's basically same output as from here, but I'm parsing it and exporting it for Prometheus. It would be possible to make it as a separate endpoint, but you will have to take care of HTTP connection, and I think that the SafeWatcher will end this way, because there are many problems with this kind of sending metrics to files and then reading it with node exporter. Any more questions? Can you give me the microphone? Thank you.
Thank you. So 2 questions kind of connected together. First one,
okay.
Did you need to do any retention on the database? How efficient is the storage? Do you keep the data forever, or do you keep the last 6 months?
We can take a look. There is some configuration option in Prometheus, and it's capable to prune your data, delete all old ones. We are running Prometheus for, I don't know, 1 month or 2 months. And it's actually storing 8.5 gigabytes of data with the system. So it's actually, I think, can be 2 or 3 gigabytes. And it's fairly clever. It tries to store all information needed in memory. So it can consume a huge amount of memory, but it can delete it from memory after some times. So it's trying to use memory as a cache, but make a regular commits into your disk. And don't try to run out of the space. I have tried once when I started deploying Prometheus. It took almost a half hour to restart it, because it was doing deep rescan of all data, and I have lost some data. So you should be careful. And still, Prometheus is a really nice one, but I think it's quite in beta or alpha state. For example, if you can take a look at this, it's not working very good every time. So I will suggest to use regular monitoring systems for regular checks, and do special checks with Prometheus.
Thank you. And the second part is that, so you use the time series database as a source for alerting, or also do you think you could successfully use it to query the database, let's say to find root cause of some failures? Kind of how are you looking at that?
We use time series database for alerting. There are some, it's called alert rules, and this rule is evaluated each time when the new round of scraping is done. So it will download all your scrapes, and it tries to optimize it, so it's not doing in single time. So it do some optimization, and then the alerts are evaluated, and all the sources are in Prometheus database. So basically, it's doing alerts based on the time series database. Any more questions? Okay, thank you for your attention. And good luck keeping your clusters healthy.